In this video, we have another look at complex numbers. We're going to write each expression in standard form. So this is your standard form of a complex number. A and B here are real numbers. A is considered the real part, and B, because it multiplies the imaginary unit I, is called the imaginary part. But they're both real numbers. By definition, I is equal to the square root of -1. Also, numbers defined, the square of I is -1. And that's a property that's not possessed by real numbers. When you square any real number, you always get either a positive number or 0 if you're squaring 0. But for imaginary numbers, and that's why they call them imaginary, you can square one and get a -1. So again, notice the behavior of this. If you have a to the fourth, then you can write this as I squared, quantity squared. And because by definition I squared is -1, then that's a real number. So when you square that, it's -1 times -1 is a positive 1, you get 1. So I to the fourth is 1. I squared is -1. So when you have the square root, you're working a, say, problem, quadratic equation using the quadratic formula, and you come up with something like the square root of 7. Then you can write this in complex form by writing this as -1 times 7, and then apply your properties, and that's say, okay, that's the square root of -1 times the square root of 7. But the square root of -1 by definition is I, so we'll put the I out here so we don't confuse it with a radicand here. And there we have it. So we want to put them in this form. Now if you're adding or subtracting complex numbers, those are pretty straightforward. It's no different than just adding or subtracting polynomials. Treat the I just like an x and follow the same rules you would if you had -8 plus 4x minus, in parentheses, 2x. The only time you have to be aware or careful is when you have a square. When you have the I taken to a power, then you have to be careful that, okay, does it give me -1, does it give me a 1, and so forth. So here, in this one, I can remove the parentheses on the first one because there's nothing in front of it, so I can just write that as -I plus 4i. Then distribute here, multiplying by -1, that's -2. And then again distribute the negative, that makes it a plus 2i. And then you just combine your numbers with your numbers, your i's with your i's, okay? Like terms with like terms, so -8 and -2, so -10, 4i and a 2i. So we get -10 plus 6i. Okay, we want to write the expression in standard form, so that's implied that we also need to simplify, because it's can't do anything with this the way it is. So we want to get rid of this I. The only way we can get rid of this I is to make it square, because we know that I squared is a -1. So this is your complex number in standard form A plus BI. And if I write that as A minus BI, that's called the conjugate. Those are conjugates. They just change the sign. So on this particular one, what we want to do is we want to basically, remember, I is a square root of -1, so it's just like a radical. So when you simplify radical expressions, you have a radical with the denominator, you rationalize. Well, the same thing here. We have to get rid of the I, so we multiply by the conjugate of 1 plus I, which is 1 minus I. Numerator and denominator. 1 plus I times 1 minus I, that's the same thing as A plus B times A minus B. A plus B times A minus B is A squared minus B squared. So this is just going to give you 1 squared minus I squared. So 1 squared is 1. And remember, I squared is -1 by definition. So 1 minus a negative makes it plus 1. So this is 2. So we rationalize the denominator. Now in the numerator, we just multiply this out. So just like multiplying binomials here, it's 1 times 6, and the inner terms here, it's a minus I here, here, those terms, minus 6i, and then minus I times minus I is a plus I squared. But I squared is negative 1. So that becomes a regular number. Negative 1 and 6 is 5. So this becomes a 5. And then minus I and a minus 6i is a minus 7i. So that's all over 2. So that gives me 5 minus 7i. And it wants it in the standard form, so I just divide through by 2. And this will be 5 over 2 minus 7 over 2. Now we could make it look more like this. I'm making this a plus and then a minus. But general practice is to just leave it that form. But you could make it a plus here and a minus here. It's the same thing. We just leave it in that form. 5 halves minus 7 halves I. Again, 5 plus I multiplication times 2 plus I. Treat that just like if it was a 5 plus x and a 2 plus x. So you can use the full method, multiply the first terms out. That's 10. Outer terms, that's a 5i. Inner terms, that's a plus 2i. And the last terms, I times I is squared. Now combine like terms. Okay, 5i and 2i, that's 7i. I squared, this is a negative 1, so you can add that to the 10. 10 and negative 1 is 9. And then 5i and 2i is 7i. That's your answer for that one. And number 4, we just have powers of I. So again, you can use the fact that I squared negative 1. Use the fact that I to the 4th equals to 1. So I can look at this first one and say, okay, let's rewrite this. Let's do it this way. Several ways to do it, but we can do it this way. I squared to the 3rd, that's 3 times 2 is 6. And then I multiply by I. That's the same thing. That's I to the 7th. I to the 5th, I'm going to break that up into I to the 4th times I. And then I to the 3rd, I write that as plus here. I squared times I. And then I just leave the I by itself over here plus I. Okay, so now let's look at this. I squared is negative 1. So negative 1 to the 3rd is still negative 1. Negative 1 times I then is negative I. So we get negative I. I to the 7th then is negative I. And this is going to be plus. Then for the next one, I to the 4th is 1. We saw that earlier. So 1 times I is I. And for the next one, I squared is negative 1 times I. That's a negative I. Plus I. We got minus I plus I cancels to 0. Minus I plus I cancels to 0. So this is 0. Now if we want to really follow the directions, we would write this as 0. 0 plus 0i. Both the a and the b are 0. So that's the standard form. Of course, if you get 0, that should be kind of right, unless your instructor is real strict. Okay, the next one, multiplying this out, again, it's just like 1 minus x quantity squared, just squaring a binomial. So you can write it out as two factors, 1 minus I times 1 minus I, and use distributive property, use the full method. Or we can just use the formula for binomials. When you square binomials, always just square the first term. That's 1 squared. Whatever the sign is, that's minus. Double the product, so that would be 2i. 1 times I times 2. Plus the second term squared. I squared is negative 1. And that combined. Well, 1 and negative 1 give me 0. So the answer is really negative 2i. I could make it 0 minus 2i to get it in that form. Okay. But that's really the answer, minus 2i, or 0 minus 2i. This one, I to the 100th power. Again, we can make it easier here by just saying, well, it's I squared. I to the 100th power is the same thing as I squared taken to the 50th power. Properties of law, properties of exponents, you multiply the exponents, so this is the same thing as I to the 100th. And we know that I squared is -1. And 1 or -1 to any even power is always going to give you 1. -1 to the 50th is 1. Thanks for watching. We'll see you next time.